So to finalize this topic, we are going to cover one more section, which is fundamentals of calibration process. Again, just to remind you that a calibration is about tuning the model so that its behavior better matches reality. It means that we adjust parameters until the model fits observed data. And here the key question is why we need a calibration. The answer is really very simple. If during a validation you have found out that the model is not able to reflect a realistic behavior, so you need to do something. And again, a calibration is something which can be helpful in a validation process, meaning that maybe you just need to adjust some of the parameters and everything will be fine. So let's discuss in a light. Okay, so as I have stated, a calibration means adjusting model parameters so the model better matches the reality. It should be stated that a calibration is iterative process. We adjust parameters, run the model, compare with real data, and repeat. We focus on the most important parameters, such as arrival rates, service times, maybe routing probabilities. It depends from the model. And of course, real data is used as the reference. So the only warning probably which should be stated that we must be careful, meaning that too much calibration can lead to overfitting. And overfitting means that a model fits well a current data but performs in a poor way in a new situation. So the following slide represents a calibration simple workflow. So first we collect real system data, then we define key model parameters and run the simulation. Next we compare the model outputs with real KPIs and adjust the parameters. A following cycle is repeated until the model is accurate enough for its purpose. So, of course, the following workflow is really very generic, but I would like to give you some practical, let's say, or share my practical experience, and it is the following: that, of course, the number of the parameters which you would like or which you are planning to calibrate. It should be a few key parameters, usually from 1 to 3, because too many increases the risk of overfitting. And now a practical, maybe not the advice, but the comment. It has been stated that first of all you need to collect the real system data. But guys, to be honest, a calibration is really very useful when we are not able to collect the real data because of different reasons. Okay, because of different reasons. As example, some of you, I hope all of you, but let's use the word some of you, already try to utilize a vSIM to build a traffic simulation model. Okay, most probably a basic manual which was provided is not the thing which goes too deep inside, but as example, a traffic model has some parameter like the level of driver aggressiveness, meaning that of course it's really very different from country to country. Let's just compare, at example, the behavior of the drivers in Italy, sorry Italian students, and the drivers in Latvia. Of course, the behavior is different. Now it's clear that a following parameter is playing really a very significant role in the development of such models. So, but the question is how to measure it, because a vSIM, a simulation software, will ask you to provide some numerical value, and the question is how to get a following numerical value. And in this case, I believe the following case demonstrates really very well of how a calibration can be used. So meaning that we could just stay with a default value, we could try to see what is the behavior of a traffic, and we could adjust the following parameter, aggressiveness level, to get more realistic behavior of a traffic flow. So, okay, this one is a key takeaways slide dedicated to the topic of calibration. I know that most probably there are not so much information which I have provided in frame of this section, but I really hope that you catch up why a calibration is important, when to use the calibration, and what kind of limitations exists when we are applying the calibration.